Welcome to Nardar Academy. In this video, we are going to do problems in three different types. The first one is how to find the integral surface passing through a given curve. The second one is to find orthogonal surface. The third one is solving compatible system of first order PDE. Okay, the first one is integral surface passing through a given curve. So this curve will be given to you, PP plus QQ equal to R. Okay, this is a first order partial differential equation. We know how to solve this. That is, first for solving this equation, we write the auxiliary equation dx by p equal to dy by q equal to dz by r. Their solution are given like this: u equal to u xyz equal to c1 and v xyz equal to c2. See, I have already uploaded one video for different types of methods available for solving first order partial differential equations. The link is given in the description box. You go through that video. Okay. So for this equation, the solution given by means of this auxiliary equation. So the final solution will look like this: u equal to c1 and v equal to c2. So these are two independent solutions. So after finding the solution, here one curve will be given in the question. Okay, that for that curve you write the parametric equation: x equal to x of t, y equal to y of t, and z equal to z of t, where t is the parameter. Okay, you write the parametric representation of the curve. Then using this parametric representation, we eliminate the constant c1 and c2 from the solution. That will give you the integral surface passing through a given curve. So simply, what is the procedure? Find out the solution for the given equation. Right, from that solution you eliminate the arbitrary constant c1 and c2 by using the parametric equations of the given curve. Okay, that's all. So while doing the problem, we can understand better. So the first problem is find the integral surface of x into y square plus zp minus y into x square plus zq equal to x square minus y square into z, which contains the straight line x plus y equal to 0 and z equal to 1. So this is the given differential equation. See, this is of the form PP plus QQ equal to R. This capital P, Q, R are functions of purely X, Y, Z. No P, Q terms should be there. Okay. So capital P equal to X into Y square plus Z, and Q equal to minus Y into X square plus Z, and R equal to X square minus Y square into Z. So what are the auxiliary equation? Dx by P equal to dy by Q equal to dz by R. So for finding the solution of these equations, we have to take equations two equations at a time, and we have to solve. Okay, right. Now look at this equation. See, if I do x dx plus y dy minus dz, here, see here xy square term is there and xz is there, and here what? Yx square. So the same term with negative sign, and yz minus yz is there. Here x square z and y square z is there. So you multiply this by x on both numerator and denominator, multiply this by y on both numerator and denominator, and subtracted dz. Okay, then you will get 0 in the denominator, right? So x dx plus y dy minus dz, if you do, you are getting 0 in the denominator. That means this numerator is a constant. So if you integrate the numerator, you will get a constant. Okay, so x square by 2 plus y square by 2 minus z equal to constant k. Right? You take LCM. So simply what you get, x square plus y square minus 2z equal to some constant c1. So first solution is obtained. For the second solution, again you look at this one. Now you divide this by 1 by x. Okay. So 1 by x dx plus 1 by y dy plus 1 by z dz. What do you get? Y square plus z. Again you get the denominator as 0. So the numerator, integration of the numerator is a constant. 1 by x dx is nothing but log x. Log x plus log y plus log z equal to log c2. So, okay, so finally what you get? Xy z equal to c2. Okay, right. So xy z equal to c2. So two solutions we have obtained. One is x square plus y square minus 2z equal to c1, and xy z equal to c2. What is the given equation? The given equation is x plus y equal to 0 and z equal to 1. This is the equation of a straight line. Okay. Now after obtaining this solution, we have to eliminate c1 and c2 using these two equations. See, here I have used the method of parametric representation. Okay, that is not a compulsory one. If you can do it by simply with this equation, that is simply by using these two equations, if you can eliminate this constant, that is well and good. Okay, right. Now let me show you how to eliminate by using the method of parameters. Otherwise you can simply substitute z equal to 1 means what will you get? Xy equal to c2, right? Here also x square plus y square equal to c1, and x plus y equal to 0. No, so from there also you can find out the values of c1 and c2. That is also allowed. but here I am going to make use of parametric representation. So parametric representation here, x plus y equal to 0, straight line only, no. So if I take x equal to t, obviously y will be what? Minus t. So x equal to t, y equal to minus t, and z equal to 1. So you substitute it in both the equations. So what you get here, t square plus t square minus 2 equal to c1, here minus t square equal to c2, or simply c2 equal to minus t square, right? And from here 2t square minus 2 equal to c1. So instead of this t square you substitute minus c2, so minus 2c2 minus 2 equal to c1, or simply c1 c2 values you substitute it from this equation. Okay, so minus 2xyz minus 2 equal to x square plus y square minus 2z, right? So this is the solution of the given system. Okay, that is integral surface, right? Next one, find the equation of the integral surface of the PDE 2y into z minus 3 into p plus 2x minus z into q equal to y into 2x minus 3, which pass through the circle x square plus y square equal to 2x and z equal to 0. Now write the auxiliary equation dx by p equal to dy by q equal to dz by r. What is capital P? Capital P is coefficient of small p, capital Q is coefficient of small q, and r is the xy terms that are in the right hand side. Okay, now look, first let me take dx and dz. Okay, so here I have y terms, no, so that y get cancelled, I will get purely x and z terms. So by taking these two terms, I am getting 2x minus 3 into dx equal to 2 into z minus 3 into dz. Okay, so if you integrate, what do you get? X square minus 3x equal to z square minus 6z plus c1, or simply x square minus z square minus 3x plus 6z equal to c1. Next, for the second solution, I am going to consider x dx plus 3y dy minus z dz. Okay, so 2xyz, the denominator it will be 2xyz minus 6xy plus 6xy minus 3yz minus 2xyz plus 3yz. So denominator getting it as 0. That means integration of the numerator is constant. So x square by 2 plus 3y square by 2 minus z square by 2 equal to constant. Otherwise x square plus 3y square minus z square equal to c2. Okay, so I have obtained both the solutions. One is C1, another one is C2. Now the given curve is the circle x square plus y square equal to 2x and z equal to 0. So if you take x equal to t, if you substitute it here, what will you get? Y equal to 2t minus t square the whole power 1 by 2. That is square root of 2t minus t square. So let us substitute the values of x, y, z in the given obtained solutions. Okay, x square minus z square minus 3x plus 6z equal to c1. This is the first solution. And second one is x square plus 3y square minus z square equal to c2. You substitute the values for x, y, z. So here I will be getting it as t square minus 3t equal to c1. Here t square plus 3 into 2t minus t square equal to c2. So by simplifying I am getting it as minus 2 into t square minus 3t equal to c2. But this is nothing but my c1. So minus 2 c1 equal to c2. Now in the place of c1 and c2 you substitute these values and simplify. So I am getting it as x square plus y square minus z square minus 2x plus 6z equal to 0. So this is the integral surface passing through the given circle. Okay, right. Next one we are going to find the surface orthogonal to a given system of surface. Okay, two different methods I am going to discuss here. That is, two different method means depending on the question given, that is the partial differential equation given to you, we have two types. One is if the given equation is of the form f of x y z equal to c. In that case, you find dou f by dou x, dou f by dou y, dou f by dou z, and substitute in the equation p into dou f by dou x plus q into dou f by dou y equal to dou f by dou z, and you solve and you get the equation as get the solution as u equal to c1 and v equal to c2, and eliminate c1 and c2. Okay, that is as before the previous problem. Previously we find out the integral surface, no? So like that you do, you will get the surface orthogonal to a given system. So what's the procedure? From f you find the partial derivative with respect to x, y, z, write the equation in the form pp plus qq equal to r, and from there you have to proceed as like the previous problem. Okay, then you will get the orthogonal surface. Second one is, suppose the question itself is given in the form pp plus qq equal to r, then the solution is given by, that is the orthogonal surface is given by p dx plus q dy plus r dz equal to 0. Okay, right. Now let's see the problems. First problem, find the surface which intersects the surface of the system z into x plus y equal to c into 3z plus 1 orthogonally and pass through the circle x square plus y square equal to 1 and z equal to 1. So this is the first type. The equation is given in terms of f, no derivatives are there. So let me take f equal to, that is the given equation, z into x plus y by 3z plus 1. Okay, so this is the given equation that I have taken. Find the partial derivative with respect to x, y, z. Dou f by dou x is equal to simply z by 3z plus 1. Dou f by dou y equal to simply z by 3z plus 1. And dou f by dou z equal to what? Here u by v method. So x plus y into 3z plus 1 into 1 minus z into 3 by 3z plus 1 the whole square. Okay, so if you simplify, you get simply x plus y by 3z plus 1 the whole square. Okay, then after finding the derivatives, you have to substitute in this equation p dou f by dou x plus q dou f by dou y equal to dou f by dou z. So if you substitute p into z by 3z plus 1 plus q into z by 3z plus 1 equal to x plus y by 3z plus 1 the whole square. Throughout you cancel 3z plus 1, so you get pz plus qz equal to x plus 1 y by 3z plus 1. So this is of the form pp plus qq equal to r. The solution is given by means of the auxiliary equation dx by z equal to, that is dx by p equal to dy by q equal to dz by r. Okay, now you take these two equations, simply you get what? X minus y equal to c1. Next, I am going to take x dx plus y dy minus z into 3z plus 1. So there I am getting x square by 2. That is, the denominator will become 0, no? So integration of the numerator is constant. So x square by 2 plus y square by 2 minus z cube minus z square by 2 equal to constant. So simply x square plus y square minus z square minus 2z cube equal to c2. So these are the solutions. So as in the previous problem, we find the integral surface, no? The same way you have to proceed. So after that, the given curve given, no, x square plus y square equal to 1 and z equal to 1. From this you have to eliminate this c1 and c2. In the previous problems I have shown you how to eliminate by using parametric equation. Now here I am not going to make use of the parametric equation, directly I am going to do. Z equal to 1 they have given, no? So if you substitute z equal to 1 and x square plus y square equal to 1 in this equation, x square plus y square is 1, no? So 1 minus 1 is 0. Okay, right, 1 minus 1 minus 2 into 1. So c2 equal to minus 2. Okay, so substitute just c2 equal to minus 2 in this equation, you will get the solution as x square plus y square minus z square minus 2z cube equal to minus 2. Okay, so that's all. So this is the orthogonal system to a given surface. Then next problem. Find the family of surface orthogonal to the family of surface given by y plus z into p plus z plus x into q equal to x plus y. This is of the form pp plus qq equal to r. So directly we can find the solution, right? See, this is the equation, no? Y plus z into dx plus z plus x into dy plus x plus y into dz equal to 0. Just you look at this term, all are linear powers only. So let me try to rewrite in this form. Y dx plus x dy. Okay, plus here z dx. Z dx is there, no? Z dx plus z dy. Okay, so z into dx plus dy. Next here what I have, x plus y into dz. Now this is nothing but differentiation of xy, and together these two terms, you look at this one, z into dx plus dy plus x plus y into dz. This is nothing but product form, no? So this is nothing but differentiation of z into x plus y. So if you integrate xy plus z into x plus y equal to c. So this is the orthogonal system. Okay, that's all. Then the next topic is compatible system of first order equation. See, you will be given with two systems. One is f of xyz pq equal to 0. Another one is g of xyz pq equal to 0. Two first order equations will be given to you. You have to check whether they are compatible, and then you have to find the solution. Compatible system means the solution of one system will be solution of the other system also. See, this is one particular partial differential equation, no? And this is another partial differential equation. If every solution of this equation is also a solution of this equation, then the two equations are said to be compatible. Okay, now the condition for checking the compatibility is Jacobian of, that is fg, we say it as box of fg equal to 0, that is Jacobian of fg with respect to xp plus p into Jacobian of fg with respect to zb plus Jacobian of fg with respect to yq plus q into Jacobian of fg with respect to zq equal to 0. If this comes as 0, then the system is said to be compatible. Okay, we will do one problem for this. See, show that the following equations are compatible and hence find the solution. Xp equal to yq and z into xp plus yq equal to 2xy. See, let me take here f equal to xp minus yq. That is, bring all the terms to left hand side and take that as f, and here also zxp plus zyq minus 2xy. This is taken to be g. Find all its derivative, that is derivative with respect to xy, pq, z. So fx equal to p, fy equal to minus q, fp equal to x, and fq equal to minus y, and fz equal to 0. Similarly here for g. gx equal to zp minus 2y, gy equal to zq minus 2x, gp equal to zx, and gq equal to zy, and gz equal to xp plus yq. After finding all this, I am going to find the Jacobian value. Okay, so if it is equal to 0, the system is compatible. So what is Jacobian of fg with respect to xp? Dou f by dou x, dou f by dou p, dou g by dou x, dou g by dou p. Okay, you know the Jacobian value, no? So you substitute it here. So dou f by dou x is what? P. So okay, then dou f by dou p. Dou f by dou p is what? X. So p x in the first row. Second row will be what? Dou g by dou x. Dou g by dou x is this one, and then gx. Okay, gx second row is what? Second one is what? Gp. Gp is what? Zx. Okay, then next one p into f is it. F is it is 0. Fp. Fp is what? X. So 0x. Next one is gz. What is gz? Xp plus yq. Next one is gp. What is gp? Zx. Plus next one is fy. What is fy? Fy is minus q. Next one is fq. Fq is what? Minus y. And then gy. What is gy? Zq minus 2x. Next one is gq. What is gq? Zy plus q into fz. Fz is 0. Fq is minus y. And the next one is gz. Gz is xp plus yq. Next one is gq is zy. Okay. Now, what is the expansion of this determinant? Zpx minus x into zp minus 2y. Okay. Then this one is 0 minus x into xp plus yq. This one is minus zqy plus y into zq minus 2x. Here this one is q into 0 plus y into xp plus yq. So after doing all this, I find the value is 0. Therefore, the given system is compatible. That means solution of one equation is always a solution of the other one also. Okay, now we have to find the solution. For finding the solution, two equations are given here, no? Xp equal to yq and z into xp plus yq equal to 2xy. See, in the first equation, they have given xp equal to yq. Substitute this in the second equation. Okay, so what will you get? Z into 2xp equal to, that is xp plus xp will be what? 2xp. Z into 2xp equal to 2xy. Isn't it? Z into 2xp equal to 2xy. That means zp equal to y. Therefore, p equal to y by z. So, if p equal to 1 by z, you substitute in this, you will get what? Q equal to x by z. Now, how to find the solution? Put dz equal to p dx plus q dy. So, dz equal to p is what? Y by z dx plus x by z into dy. Cross multiply. So, z dz equal to, this side it is y dx plus x dy. No? So, that is nothing but differential of xy. So, if you integrate, z square by 2 equal to xy plus c. So, this is the solution of for both the equations. Okay. That's all. Thank you.